Uh, Welcome to the final module, first session. Uh, Let us discuss about the syllabus which is there in your university for the first year elements of mechanical engineering. This is fifth module. In this fifth module, we will be talking about basically machine tools. Machine tools will be the one which makes our things the work easier. Say for example, drilling machine which makes easy for us to drill the hole. Similarly, a lathe. Similarly, milling machine. So there are many machine tools are there, out of which, as per the syllabus, we have to study the lathe, milling machine, and then the drilling machine. And later we will also discuss the introduction to advanced manufacturing systems, that is computer numerical control as well as the robots. So before I just proceed with this CNCs and the robots, let us discuss the lathe. Lathe is also one of the major machine tools. Among all machine tools, lathe is the one which has been extensively used in all the industries and automobile sectors. So let us study what is a lathe, how it has been used, and then the principle of working of a center lathe. There are different types of lathes are there, out of which, as per your syllabus, only the center lathe is being used. Then we will also study different parts of the lathe, and then the operations of the lathe, the different what all the different operations that can be performed in the lathe. Okay, it may be a turning operation. We will go in detail what do you mean by a turning operation. So in which in the turning operation, any materials diameter will be reduced. Say for example, if this is a 12 dia, it will be reduced to 10 dia. And then we will also have a facing operation. In the facing operation, as the name itself indicates, the diameter, that is the overall length, will be reduced. The length of the workpiece will be reduced in the facing operation. And then we will also have a knurling operation. Knurling is something that in order to get grip, in which actually knurling we are not going to remove the material, but we are going to make an impression onto a shaft so that it can be easy for holding. Is it clear? As I go through that in detail when I talk about the knurling operation. Then the thread cutting operations. Threads, you must be knowing it. Even when you see this, now this is the threadings. Not on the plastics, actually on the metals, it will be used to make the threads. Okay. Now then drilling operation is there. Drilling operations can also be performed using a separate drilling machines also. That we shall study in detail actually. Then taper turning by tailstock offset method and compound slide swiveling method. There are two types of taper turning. Taper, tu- Taper turning is one process wherein which the diameter over here is different than the diameter over here. So it is something like a converging or it may be a diverging section. A gradual increase in the diameter or gradual decrease in the diameter. That is what we call it as a taper turning. This taper turning can be performed by two methods. One is a tailstock offset method, and then the compound slide swiveling the compound rest method. Two methods have been used in this lathe to perform taper turning, and then specification of the lathe will also be studied in this. Okay, now let us come to the milling machine. Apart from this lathe operation, we also have a milling machines. These milling machines, we will study what are these milling machines and principle of milling machines, and then the types of milling machines. Okay, working of working of a horizontal and vertical milling machines we will study. And then the milling processes, plain milling and end milling, and then we will also have a slot milling, angular milling, form milling, and the straddle milling. There are the different types of milling operations actually, and we will also have a gang milling wherein we will not be we will not be going in depth except the layout sketches of above machines need not to uh, be dealt actually. The sketches need to be used only for the explaining the operations of the performed on the machines that is required. Okay. Next we will also study introduction to advanced manufacturing or advanced manufacturing systems. Now actually as the manufacturing is getting advanced, the requirement of these conventional machine tools has to be increased or it has to be more sophisticated, and even this has to be advanced. So keeping that in context, so we will introduce a computer interface machines which operates it without a human interaction while during the process. Computer numerical control, as the name itself indicates, controlling any machine tools using a computer in which a series of numerical codings have been used in order to control the working of a machines. Introduction, that is we will discuss about the basics of the CNCs, and then the components, what are the different components of CNCs, and then there are two different types of CNC systems are there. One is an open loop and the other one is a closed loop systems, and we will talk about the advantages of CNC and CNC machining centers and turning centers. Okay. Now, one of the till it has been termed as one of the most advanced technology is using robots. Robots. What is a robot is a very interesting. We will discuss in the last chapter of this module. That will be the last topic in your syllabus also. Robot anatomy, joints and links, and we will also talk about the common robot configurations, applications of robots in materials handling, processing, and assembly and inspection. This is what it is all there in your syllabus. Now, trust me, whether it is a conventional or advanced, but these all machineries or all this processing comes under the category of machine tools. Machine tools are the one which are actually performing these works. Nowadays, the machine tools have been so famous. Even you might have observed in uh, the construction field or even in the automobile field, to make the bolt tight and to remove the bolt also they have the hand machine tools to tighten it and to loose it also. Say for example, if you have a big tire, you have to remove it. There will be four or five bolts will be there, and that will also be tightened and removed by machine tools. Earlier we used to take a spanner and we used to make it tight or make it loose. So this is what an advancement in the sector of machine tools. Basically, what is this machine tools? What are these machine tools? To be frank, now if you check this, one of the important one is a metal cutting thing. So if we have to talk about what is a machine tool, a machine tool is a machine for handling or machining metal or other rigid materials. Maybe it may be a ceramics, or it may be a glass, or it may be the rocks. If you go for a granite, how it will be cut? Using a milling, or if it is a cutting machine. It is nothing but a machine tools. It is not necessary for a metal also. It can be used for any rigid material like a hard plastic, rocks, glass, is it composite materials. Usually by we will machine it using, what do you mean by machining then? It is nothing but cutting, boring, grinding, shearing, and other forms of deformations. That the permanent deformations what we it meant to occur, that is what we call it as machining. The tools which have been used for this purpose is called as machine tools. All the machine tools have some means of constraining the workpiece and provide a guided movement of the parts of the machines. Thus, the relative movement between the workpiece and that cutting tool, which is called as a tool path. If it is moving like this, no, even if you have a drilling, if I am drilling a hole, the tool path will be in this direction. Correct? If you are removing a bolt, the tool direction will be in this way. If you're cutting a workpiece, say if this is my hand is workpiece, uh, using a saw or using a power axa, if I'm cutting this, the tool movement will be like this. So along the path it will move it and make it to cut. So that is what we call it as the tool path, or the one which is being used is called as a cutting tool. The machine is different and tool is different. Tool can be changed. Okay, that I just shall discuss it now. Is this cutting tool can be controlled and constrained by the machine, at least for some extent. It's only because if I want to cut a material, if I want to cut this material, I cannot cut it with in a space. So what I will do it is I will restrict it with holding it tightly. Then I will cut it. It is a common sense. It is a common sense. If you have a sharpener and a pencil, if you want to remove the material, you have to hold this constant. You have to hold the sharpener, restrict this movement, and then you have to rotate the pencil, isn't it? So the same way, we are going to restrict the workpiece. We will make it constrained. That means it will not be allowed to make any movements in any of the directions. Is it clear? That is what we call it as restricting the uh, the work pieces, and we will be making the tool to move or rotate or any movements which will have a degrees of freedom later. Okay. Now, rather moving the entire half hand or a free hand, is the power driven by these metal cutting machines, which assist in managing needed relative motion between a cutting tool as well as the job that changes the size and shape of the workpieces. Now, if you make a pencil sharper, it is getting it into a conical shape. If you want to cut it, so it will give a different shape and size, isn't it? So that is what, if you want to make a drill a hole, it will give a different size or shape of the job material, or what we call it as a base material, or it is a workpiece. So when we go for a first year workshops, we always say it as a workpiece on which we are going to make it. Is it clear? The precise definition for a machine tool can be given by various. Say for example, it can also be defined as machines which helps us to make things, or you can also define these machine tools are the one which makes our uh, things easier, makes things easier. So that is the use of these machine tools basically. And these machine tools can be different tools. Say for example, this has been introduced in the 20th or 19th century, and nowadays without a single wire radium, and there is a one machine within which the wire radium is also there. Okay, even no need for the tool, a strong wire itself will cut the material. So much of advancement has been come in the machine tools. Basically, these machine tools can also be a power driven or it may be a hand driven. Now drilling machines are there. I'll press a button, it will drill a hole, and there are some means of drilling machines where I have to rotate it so that it will make a hole. So it may be a hand driven. In 99% of the time, we will go for a power driven. It is only because it reduces our strength and increases uh, the speed of the work, isn't it? So it can be defined that even in the machine tools there are different types of machine tools are there. Examples we would like to take it as a lathe, milling machines, grinding machines, which being used to cut, shape, and finish the materials. They sell grinders or machine tools in a based on different applications, based on uh, the machine requirements. It may be a lathe, or it may be a drilling machine, or it may be milling, or it may be grinding, or it may be buffing machines. Okay, different machines are there, machine tool. Several metal cutting operations are being carried out to produce a mechanical part of required shape and size, or it may be for any deformation also. The metal cutting operations may be carried out either manually by using hand tools such as chisels, files, saws, etc., or maybe using metal cutting machines. When machines perform the metal cutting operations, by the cutting tools mounted on them. They are called as machine tools. A machine tool may be defined as the power-driven machine which accomplishes the cutting or machining operations onto it. That is what you can define anything. Its only thing is it makes the work easy for us and it accelerates the work. Is it clear? The fundamental machine tools that have been used are something I have already uh, made a note. Lathe or it may be drilling and milling grinding. Now let us talk about lathe machine tool or a lathe machine. In this lathe machine, we can perform different work. In the different work or a process, we have to use a different machine tools. It's clear. Now, a lathe is a machine tool which turns cylindrical material. A cylindrical material is something like this. It is a cylindrical material. It has a length and it has got diameter. It has a diameter and it has got a length. This is what we call it as a cylindrical material. Touches, I mean, it turns the cylindrical material, touches the cutting tool to it and cuts the material. It is said to be mother of all the machine tools. This is what I have been talking. Among all machine tools, lathe is one which is called as a mother of machine tools because it can perform various activities, various processing, various metal cutting operations. It may be drilling or it may be a knurling or it may be a thread cutting. So these things are not possible. Say for example, if you take a drilling machine, its duty is only to drill the holes with a different diameter, that is secondary. Okay, whereas in a lathe it can also perform the drilling operation also, but it will be for only the cylindrical materials. But it can also operate it on the other cubes also, but it will be more effective for a cylindrical materials. The lathe is the oldest of all the machine tools and most basic tool used in all the industries. Is it clear? So a lathe can also be defined as a machine tool which is primarily used to produce circular objects and is used to remove excess material by forcing a cutting tool against a rotating workpiece. Is it clear? Now what happens here, there are two methods. One is the tool will be moving or the workpiece will be fixed. Whereas here what happens in the lathe, all the operations will be carried out by keeping the tool constant and the workpiece will be made to rotate. That's the beauty. Okay, except maybe in the drilling operations where we are going to fix this drilling bit to the head race. I'm sorry, uh, major this one jack does. Actually, what happens here is it is something like a pencil and how we sharpen it. If you see this is an eraser. If you see this is an eraser, what we will do it is we will fix this eraser and we will rotate the workpiece. Now the which one do we call workpiece? A workpiece is one material for which we are making alteration in its size and shape. So that is what we call it as a workpiece. Say for example, now this is a tool. A sharpener is a tool and a pencil is your workpiece. So what we will do it is we will fix this tool. We will fix the tool and we will keep rotating the workpiece. Now the workpiece is been rotated so that what is happening is deformation or alteration is being happening for the pencil, that is your workpiece, whereas the machine tool the tool is being fixed. This is what happens in your lathe machines. In the lathe what happens, the workpiece is being made to rotate, whereas the tools have been fixed. That is first point. Second point is it will operate it for the cylindrical materials. Is it clear? It can operate it for metals and it can operate it for even the wood, plastic or whatever it may be. Anything can be used. Is it clear? Now this is the principle of working between of a lathe machine. Now the lathe is also the excess of a circular lathe is been defined as a machine tool is primarily used to produce a circular object. That is what, and is used to remove excess of materials by forcing a cutting tool against a rotating workpiece. Is it clear? Now, lathes are also called as a turning machines. I'll tell you why it is a turning machines, because we will make the workpiece to turn, rotate. Is it clear? Since the workpiece is turned or rotated between two centers, okay, it is since it is so versatile that almost all the machining operations which are performed on other machine tools like drilling, grinding, shaping, milling, etc. can be performed on this lathe machines. Working principle. This is what actually. Now, my dear friend, this is um, the chuck is a place where there will be three jaw chuck and four jaw chuck will be there. So something like this. If there are four things are there to hold the workpiece, then we call it as a four jaw chuck. If it is a three uh, teeth are there, then it is called as three jaw chuck. If it is a four, it is called as a four jaw chuck. If it is a three, it is called as three jaw chucks. Is it clear? No, this is being extensively used. Based on the grip which is been required, we will hold it. Now what happens here, it just holds the workpiece, and there will be a spindle which makes it to rotate faster. Now as you can see it in the sketch, this is the workpiece which is being made to rotate faster, and this speed can also be varied depending upon the surface finish we are just required. Now this is a headstock. Headstock, there are different parts actually. There will be a headstock and there will also be a tailstock. In the headstock, what happens, we will fix the workpiece and we will make a support, because if it is a too long, what happens, it wobbles when it rotates, right? So what we will do it is, we will give a support to this, so that what happens, it rotates faster. As it rotates faster, a fast rotating element, if we make much harder machine tools, as you can see it here, a strong point out tool will be there. When we make this tool to touch this against a fast moving workpiece, then what happens, a material will be removed. The material which is coming out, which we call it as a chips. Now, as I was just talking, even in your sharpening the pencil, when you are sharpening the pencil, the waste material will be coming out of this the sharpener, right? So that is what we call it as a chip. Chip is a chip is a material, a waste material of the workpiece which is coming out because of the machining operations. Is it clear? Now, a workpiece will be folded here and it is being made to move faster. Now there is a tool. Tool can be made to move a depth in and out. It can move in this x plus x and plus x and minus x, and it can also move it in plus z and as well as the minus z directions. It will have 2 degrees of freedom. That means a tool can move in and out, and it can move to and fro. It can go inside and outside, and it can move left and right. So that is the movement. If you are moving towards the left, no, that is what we call it as left and right is called as a longitudinal feed, and in and out we call it as a depth of cut. Okay. Now this is how the tool is been. Tool will have a single point tool. Single point tool means a pen or a pencil will have a one point edge, right? So this is what we call it as a single point tool. If you have a axa blade or a axa or a saw, you might have seen it. Saw to cut the wood, it is called as a multi-point cutting tools. So that means there will be multi-points will be there in order to make it cut. If you take a blade, blade is a multi-point cutting tool. Whether you take a pin, it is a single point cutting tool. Are you getting my point? So that is the difference between a single point cutting tool as well as a multi-point cutting tool. So this is a check. This is a headstock and tailstock. Headstock is the place where we are going to fix the material. Tailstock is the one which supports the workpiece. It will not rotate. It is only to support. The major power or the major energy will be passed through the headstock, where it makes the workpiece to rotate with certain speed. That will be in terms of revolutions per minute or revolutions per second. Is it clear? The centermost point which tells us an axis. Any shaft or any cylindrical thing, whatever the centermost point which is been given in axis, which is with the dotted lines. You might have studied in your CAD or a drawing subject. So this is an axis. Whatever the material that is being removed, since it is rotating, whatever the material is being removed, it will be uniform, it will be symmetric, isn't it? If you take a pencil, whatever the material that will be removed, it will be uniform, right? It will not be more on one side, it will not be less on the other side, isn't it? So that is the what. And then we will also have a chips that is being removed from this material. If you want more, see for example in this sketch, what we are doing, it is we are making the tool to move leftward towards the left side. So what is happening is, so much of diameter is been reduced. It is reducing the diameter. If I give it as a depth of cut, if I keep moving the material to a deeper, then what happens, the material will be cut and the length will be reduced. Whenever I give a more depth of cut, the length we can reduce it. That is what we call it as a phasing. So the same thing, if it is we are moving in a longitudinal direction, we are reducing the diameter of the workpiece. Okay, let us take a look to this. A lathe basically it's a turning it's a turning machine which works on the basic principle that a cutting tool can remove material in the form of chips. Even in these chips also we will get two types of chips. Actually one is a continuous chip and the other one is a discontinuous chip. I would like to give you an example for this continuous chips. If you are removing a pencil like this, whatever the chips or whatever the element, whatever the material, the wood material or it may be the pencil material which is coming out, if it is a continuous, that means if the length of the chips is continuous, it may swirl like this, like a spring or a rings. It swirl like this continuously, then we call it as a continuous chips. If it is a discontinuous chips, it will be small particles. It just comes out. It just comes out. There will not be any continuous like a threadings. It will be a discontinuous. Are getting my point? So that is what we call it as a discontinuous chips. So the continuous chips and discontinuous chips depends upon the speed, feed, depth of cut, all those things it will come into picture. Let us not worry about it. Okay. Now this can remove the material in the form of chips from the rotating workpieces to produce circular object. This is accomplished in a lathe which holds the workpieces rigidly. That means a workpiece will be holded rigidly, but it will be free to rotate. Please point to rotate. I'm just holding this. I'm just holding this firmly, but I will be rotating this. Is it? That means its degrees of freedom is being fixed. That means it is free to rotate, but it is not free to move here and there. Is that clear? Say for example, now I am holding this and I am making like this. So it is free to move only in that particular rotation. That's it. Is it clear? So this has been accomplished in a lathe which holds the workpieces rigidly and rotates them at a very high speed. Maybe 200 rpm, 300 rpm, 400 rpm, 1000 rpm also it can rotate. With a cutting tool is being moved against it. Okay, the workpiece is held rigidly by one of the work holding devices. It may be known as the chuck. Chuck is the one which holds it. Even here we have a 3-jar chuck and 4-jar chuck, not 2-jar chucks. It's only because to have a firm grip we require a 3-jar chuck minimum, and then we will also have a 4-jar chuck. Only two types are there: 3-jar chuck or 4-jar chuck, which holds the workpieces. Then a cutting tool held against the workpiece opposite to its direction of rotation when moved parallel to the axis of the workpieces produces a circular surfaces. Okay, though It may be of any shape. Maybe it may be because of the square. It can be a square bar also, bar element. It can be reduced into, it can be made into a circular bars also by removing an extra materials. Okay. Opposite to its direction of rotation when moved parallel to the axis of the workpieces produces a circular surfaces. The material of the tool will be harder and stronger than the material of the workpiece. Obviously, my dear friends, if you have to remove the pencil, if you have to make the sharper, then obviously this sharpener blade should be stronger than this, right? Is it? If it is both of the same material, then what happens? It cannot remove it. So that is what the material with which the tool is being made, which will be much, much, much stronger than the material of the workpiece to be removed. In most of the cases, the tool will be made up of high speed steel, which we also call it as HSS tool. In the next class, we shall study the different operations of the lathe.